The Smart Temperature and Humidity Logger featuring the NRF52832 development kit paired with the Neevee Peripheral Shield. It is ideal for smart homes and offices, enabling users to monitor ambient temperature conditions for comfort and energy efficiency. Integrates the Precision SA7006 temperature sensor via the Neevee Peripheral Shield for accurate environmental data capture. The 1.9-inch e-paper display uses microencapsulated electrophoretic display technology and serves as the screen for showcasing temperature and humidity values, ensures clear and real-time visualization of temperature values. The NRF52832 development kit is a versatile system on chip with powerful processing capabilities, serving as the core component for various applications. It provides essential features for development, testing, prioritization, efficiency, and performance. Supported by a rich ecosystem, it offers a wide range of resources for developers to create innovative solutions. The Arduino compatible Neevee peripheral shield seamlessly integrates the SI7006 temperature and humidity sensor into your system, with added features like ADC, DAC, accelerometer, and keypad scanner. It extends system capabilities. Designed for easy integration with the NRF52832 development kit, it's perfect for various applications. The SI7006 sensor, known for its accurate temperature and humidity measurements, the sensor communicates efficiently with the NRF52832 using a digital I2C interface. Its small size and energy efficient design make it suitable for use in different devices and environments. The e-paper display module using microencapsulated electrophoretic display technology. The screen provides high contrast visuals and save energy. With a compact size of 1.9 inches and a wide 180-degree viewing angle, it ensures clear visibility in various lighting conditions. Connected to the NRF52832 development kit through the I2C protocol, it receives the real-time updates, and its small size makes it easy to carry for space-limited applications. The NRF52832 communicates with the SI7006 sensor using the I2C protocol, a common way for microcontrollers to connect with peripheral devices. Each SI7006 sensor has a unique I2C address, allowing the NRF52832 to communicate with it without conflicts, even when multiple devices share the same I2C bus. The NRF52832 can both read from and write to SI7006 sensor over the I2C bus. To obtain sensor data, the NRF52832 sends a read command and the SI7006 responds with the requested information. The master device, the NRF52832 efficiently fetches temperature and humidity data from the SI7006 sensor via I2C communication. This data can then be processed and used for display or transmission purposes. The NRF52832 establishes communication with the e-ink display using the same I2C protocol, configuring parameters for two-way data exchange. The e-ink display has a built-in controller that interprets commands and data from the NRF52832. This communication protocol is optimized for compatibility with the display controller, ensuring the smooth updates. The NRF52832 interacts with the display buffer of the e-ink display, sending relevant data for visualizing temperature and humidity values. This process involves the coordinating data transfer to specific memory locations, and it manages power consumption of the e-ink display by coordinating low power modes when the display is not actively updating. This optimization enhances overall energy efficiency. Each e-ink display connected to the NRF52832 is assigned a unique I2C address. This allows the microcontroller to differentiate between multiple displays on the same bus, supporting the integration of various peripherals. The demo begins by setting up the NRF52832 chip and a SI7006 sensor to gather data like temperature and humidity. They communicate smoothly using a protocol called I2C, ensuring they exchange data effectively. The NRF52832 chip understands the data from the sensor, picking out the exact temperature and humidity levels. After some processing to make sure the values are accurate, the data is sent to the 1.9-inch e-paper display. The NRF52832 chip then talks to the e-ink display, updating it with the latest data for us to see. People can keep an eye on the current conditions of the display. Additionally, the NRF52832 chip can share this data with other devices using Bluetooth, so we can check it with remotely and integrate it with other systems. We are working on creating a smart Bluetooth low energy thermostat as a part of our smart temperature and humidity logger system. Our aim is to maximize energy efficiency, ensuring our devices can operate for multiple years on a single charge. We are also focused on transitioning our project into a fully fledged product for widespread use, making it accessible to everyone. In short, our smart temperature and humidity logger system offers a complete solution for monitoring environmental conditions. Our future plan includes creating a smart Bluetooth low energy thermostat and ensuring long lasting energy efficiency. We aim to make our system accessible to all users, improving comfort and productivity in various settings.